Hi, this is Matthew. Today we're going to compare three popular backend as a service platforms: Firebase, MongoDB Realm, and AWS Amplify, with a focus on Realm and how it relates to our project. So, quick intro to Firebase. Firebase is hosted on Google Cloud Platform, ensuring strong infrastructure and scalability. It also provides a variety of features. Three of the most important are user authentication. So, letting Google handle your user authentication saves a lot of effort and security concerns for the developers. And real time database as well that automatically stays in sync with your front end application. Firebase offers Firestore, which is a proprietary database owned by Google. And Firebase also provides SDKs for various platforms like JavaScript, Android, iOS, Flutter, and more. And overall, it just makes it easy to scale and manage applications with little to no backend code required. One of the alternatives to Firebase is MongoDB Realm. So MongoDB is a popular document-oriented database. It's well known for its scalability and flexibility. So the primary strength of Realm lies in its database capabilities and seamless integration with the front-end app. Realm allows you to sync data between MongoDB Atlas and the cloud to both web and mobile platforms. Having a lightweight, fully featured database embedded on the client device is great because it allows offline work in case you lose connection, and Realm handles the merging of data and conflict resolution for you. Other useful features include function triggers and user authentication. Another alternative is AWS Amplify, which is hosted by Amazon Web Services. It provides a strong set of features, including authentication, data store, and functions, as well as analytics, predictions, and more. The primary database used is DynamoDB, and Amplify automatically generates a GraphQL API for your data. And authentication is handled through AWS Cognito, which is powerful and allows for creating user groups and managing access easily.
The Firebase alternative that we chose to implement is MongoDB Realm. MongoDB Realm is a backend as a service platform designed to simplify web app development. By using Realm, developers can focus more on client-side development, like building app features and user interface. This is because backend tasks like database synchronization, server-side logic, and creating APIs are handled automatically by this platform. How it works is MongoDB Realm connects to MongoDB Atlas, which is a fully managed cloud database that handles saving, backing up, and managing your data. This connection ensures that the app and database are always in sync in real time. This means that any changes that are made to the app is automatically reflected in the database and vice versa, and updated for all users that are accessing the app. We chose to use MongoDB Realm because of its ability to handle real-time updates. This is important for a bookstore application that relies on real-time data. Using Realm, any changes to inventory or price are updated immediately to ensure consistency among different users and devices. In our application, we have a feature that recommends books to users based on what others with similar preferences have purchased. With Realm's integration with Atlas, it makes it easy for us to recognize purchase patterns to generate a personalized suggestion for each user. With these features in mind, we decided to go with MongoDB Realm as our Firebase alternative. Let's go over some of the features that MongoDB Realm offers. The first feature is real-time synchronization. As mentioned before, this feature makes sure that any changes that are made on the app are automatically synchronized with the cloud database and vice versa. This makes sure that the data stays consistent across all devices and for all users, without requiring extra work from the developers. Another feature is offline capabilities. Any app that's built with MongoDB Realm can work even without an internet connection. That means that users can continue interacting with the app, and once the connection is returned, all the changes are synchronized automatically to the database. This platform makes backend development easier by having built-in tools for data access, syncing, and API generation. This eliminates the need for a manual backend setup. Realm has cross-platform support, which allows you to write your application once and use it across multiple platforms, including web, mobile, and IoT devices. The last notable feature of Realm is that it offers tight integration with all of MongoDB's cloud operations, including MongoDB Atlas, ensuring seamless data management and scalability. Overall, MongoDB Realm offers many features that make it a good choice for web app development.
Hi, my name is Kiefer, and I'll be explaining how we implemented MongoDB into our existing codebase. So the Mongo implementation is similar to the JPA implementation. Just instead of JPA repositories and annotations, we are replacing them with MongoDB repositories and annotations, meaning that the entity classes are replaced with document classes, and all the IDs that are created in those entity classes are changed from integers to strings. I'll show you the code base that was changed. So, as we can see from our book class, that used to be an entity class, instead we made it a document where the collection is books. So this will go straight to the MongoDB and will link so we know that this is our book um, database or collection. Next, we have our ID. So this ID usually would be a generated value with JPA, but with Mongo, we can just specify that it is an ID that we change to a string instead of an int. We can do this because persistent models in JPA are run in the project code, while using MongoDB, it is run on the cloud. So the generated values are all handled in the backend. So next we can go to our book repository, which now extends a Mongo repository instead of a JPA repository. It acts the exact same as a JPA repository, it just works with our database. We can see here as well, so this carts class, now the exact same at document class, but now we have DB refs. These annotations work just the same as a many to one or a one to many in JPA, but now we don't need to specify because Mongo handles all of the backend automatically. So we just need to let it know that these will be used in throughout other classes. Now, in our actual application, to connect to our database, we use a connection string here. This connection string will ping the database and tell us that it's all connected and everything. Just in this string, you need to specify our DB name and our DB password so it can connect to that cluster.
All right, so now I'm going to do a little demo of our bookstore application, and I'm going to go through a couple of the actions that we can do within our web app, and then we'll look at what happens within MongoDB and what it looks like. So first things first, I would like to do a sign up so that we can see what it looks like when we create a user within MongoDB. So we see that it's signed up successfully. So now if we go within MongoDB and we refresh, we will see that we have the user that we created, the admin user that is created when the application starts up. So now if we go back to our web app, I would like to go into the admin user. So we have an add new book button over here. If we click that, we can add a new book. As you can see, it was added successfully. So it shows up over here, and then we'll go back into MongoDB, and we will refresh the database. And you'll see that the collection was added, and it also added the book that we created. Now going back to the application, we can go ahead and change a couple of stuff. So we can say 1, 2, 3 here, and update the book, which updates here, and also in MongoDB. You can see that the title was changed and the price and the inventory. Also, we can go and try and delete the book, and it will remove it from the database. So now I went ahead and logged into one of our customer users, and I added a couple of books to show you the adding to cart and purchasing books looks like. So you can see we have all these books, and we'll add a couple here and here, and then we'll proceed to checkout. So it says that our order was successful. So you can see all the books that were added, and we can see that the inventory is changed because we bought some of them. And then we can go ahead into our checkouts and look at every single object that was bought. So as we know, we bought 4 books, and you can see the information of each book here with their quantities and all that. And as you can see on top, we also have the user ID, which is a reference to our user that we logged into, which is right here. For anyone that is currently building a project and needs to implement a database, we highly recommend to use MongoDB because it was very easy to implement within our project, even in the later stages of development. It took us around an hour to get it working. We also found the visualization very intuitive, and it's very clean and it's very easy to understand. Anyways, that's all for us. Thank you for watching.